Hi everyone, my name is Elizabeth Marmo and this is my Physics 2211 Lab 3 presentation. In this lab, we were tasked to find various variables in a star system that orbits a black hole using GlowScript and its base code. We were then able to alter the code to reflect this orbit and solve for the mass of the black hole. We then used another GlowScript code using this found mass to solve for a ship in the surrounding and its initial velocity in certain scenarios. The purpose of this lab was to apply Newton's second law and the momentum principle to understand a gravitational force scenario. For the fundamental principles, Newton's second law, force equals mass times acceleration, allowed us to derive other necessary formulas like the gravitational force. The momentum principle was also applied to derive the force parallel and perpendicular components, as these are essential to gravitational orbit situations. Some physics errors we could encounter are inconsistent data points throughout each trial and estimating the system versus a literal one. For part 1 of finding the mass of the black hole, we adjusted the base GlowScript code at the highlighted points for our calculations. These mostly used the momentum principle to calculate the force parallel and force perpendicular, which thus solved to be our F net. As you can see, these are our changed sections, and we also adjusted the rate so that our video would have a faster runtime. As you can see on the screen, here is what our code resulted when it was ran, and the arrows represent our F net, F perpendicular, and F parallel components. As a result, we got our F net to be around 9.03 times 10 to the 28th newtons, which we also proved by adding our parallel and perpendicular forces. Using this number as our force of gravity and having our code output our final R, we rearranged the F gravity formula to solve for the mass of the black hole and got our number to be around 1.43 times 10 to the 34th kilograms. On to the second part of our code, we used the found mass and applied the force of gravity formula to the F components of our code in their respective scenarios for the initial velocity that would be safest for the passage of the ship to go around the black hole. As you can see in these sections, this is where the force of gravity is applied, and we inputted our found mass from the previous section, and thus our numbers were found. With this code, we found the initial velocity that would work is -1 times 10 to the 7th meters per second in the x direction and 1 times 10 to the 7th meters per second in the y direction. On to our what does it mean problem, asking how is the net force components different than the rate of change in momentum components? Newton's second law can be broken down into mass times the change in velocity over change in time formula, which has the same parallel and perpendicular components. For the momentum principle, dp dt is the base for the perpendicular and parallel component formulas, which sum to be F net. As you can see down here on the bottom, if we make F net equal to dp dt, the formula which derives of m equals the change in velocity over change in time is the same as the one we found with Newton's second law. And then on the what if question, whenever we rearranged the code, we were able to find that a velocity in the x direction being changed to -5 times 10 to the 5th meters per second allowed our ship to orbit the black hole without crashing in comparison to the original code. In conclusion, Newton's second law and the momentum principle are integral parts in solving a black hole system with gravitational force. With these fundamental physics principles, we were able to solve for the mass and initial velocity efficiently proven by the GlowScript code. Some errors that we encountered during this trial would be the fluctuation of data points and thus having to round numbers or find averages of numbers in order to solve, which could solve for some wiggle room between our data points and the reality of what actually would have been calculated. Thank you for watching my video.